tune, it tends to really radiate at distances for its size further than you would expect, because it's only a 4-inch ball. But yet 3 feet away is when I was seeing my little fluorescent lamp light up. But as I brought it into tune, I couldn't get anything to light up near the coil. So I was going to run that by you guys. What are your thoughts on that?
Yeah, that's weird. So you tuned the coil and the lights went out.
You know how you do the wireless, hold the light bulb next to the Tesla coil and it lights up in your hand?
I've never replicated a coil, but I've seen many people do that. Yeah.
Yeah, exactly. It did it further than your average coil when the coil was out of tune. And when I say out of tune, it was a frequency that was not close to its resonant frequency. And by the way, I haven't been able to tune my stuff within more than a 1,000 hertz range. So I
there's
still
a lot
have
of harmonics
to
the resonant frequency.
Yeah, so I have a whole 1 kilohertz to still tune it, but there are a lot of variables in that. So I have to shorten all my leads, get everything as close as possible. I need really thick copper, so that way I don't have any antennas, no sharp edges. I can then get in that perfect tune. But out of tune, and it pumps out radiant energy. In tune, it's like a different Tesla coil.
So that's very interesting. I kind of wonder if when you were doing your resonant tuning and you were lighting neon, did you go further than 3 feet? Like say even 13, 12 and a half, 13 feet?
Oh, no, not that far. It was about 2 to 3 feet, when normally my small coils are about a foot, 18 inches. Because they're so small, you see people with a 2-foot Tesla coil, you're going to light up fluorescent bulbs on the other side of the room. But no, it surprised me that little sphere lit up things with radiant energy. But when I put it in tune, it was almost like a negative spot of radiant energy.
I just kind of wonder if you were pushing that sphere of energy a lot further out than you thought, and you created a null zone.
Where the
system you could have made it more of a receiver, less of a transmitter.
Oh, that's an interesting idea. Thank you. I'm going to try that. See if there are null points.
Definitely. That's something that if you find, you're right over the target. You're getting very close to what we've seen in some of the systems that we're operating now.
Oh, thank you. That's a really good idea. I'll test that.
Awesome. Hey, Tim.
Hey, guys.
Hey, Tim.
I got the invite. Thank you for having me on.
Hi, Tim.
Absolutely. Hey.
Nice to meet you. You're kind of a legend.
Oh, thank you, Sean. I'm not a legend. I'm beat up. Especially
it's good to have you here, Tim.
Aren't we all?
Yeah. I'm gonna get Gerald to come at the APEC conference. I'll probably pull Old Man Builds back in at some point too. And I was thinking about getting Ben to come on at some point as well. But
awesome.
Yeah. So
nice.
Jared, you guys know Jared Yates, right? So I was in Reno with him last week. That was our secret mission, and so we were helping the family of Dr. Friedwart Winterberg review and archive like a lifetime's worth of fusion materials. And this guy was like, he was a heavyweight, right? I mean, he worked Werner von Braun, Carl Sagan. His doctoral advisor was Werner Heisenberg. I mean, he was he was best friends with Edward Teller, who invented the H-bomb. This guy was as big as it gets. And we got to go through all of his files, all of his documentation. And actually, that was the problem. He had 35, those big file boxes, 35 file boxes of data.
Oh, wow.
And then he had over 100 3-ring binders with every letter he'd ever written or received going back to 1957. And so it's like, okay, we had a week to go through that. So we got maybe 5% of it. And there was a lot about fusion, and he was also really into UFOs.
Awesome.
And so we learned a lot, but in a weird way, it's like we don't even know what we've learned yet. I guess this was.
Were you not wearing camera glasses while you were looking through that? I'm kidding, Tim. I'm kidding.
I was just pulling stuff out and handing it to Jared, and I'm like, dude, scan this, right? And the thing is, like Jared, like this was I'm gonna blame this entirely on Jared, right? Like I'm the victim here. Jared like absolutely loves this scientist. He's like, this guy is it. You have to come with me. You have to help me. And so I'm like there, and I'm just like, what the heck? Or I'm just like, okay, here, scan this, and so Jared is actually going through, and like if you guys touch base with him, he's already finding bits and pieces, and a lot of that just kind of escapes me. Like I know a fair amount about that area, about that fusion research, but like he has studied this, and so he's definitely the expert.
I did email Jared Yates the link to this right now, so hopefully he gets it and comes. Thank you, Tim, for joining us.
Yeah, well, maybe he'll come on. I don't know if he's, but one thing I would say is, I mean, just for what it's worth, right? Like some of the stuff that I noticed, like, okay, so nothing in his files was classified. There was stuff that was declassified, right? But like nothing in all of these files was classified. And so what we think happened there was Winterberg, he changed from a couple of companies. He was at one called Desert Research Institute. He went over to University of Nevada. I think that when he changed companies, him or somebody else went through all those files and removed the classified stuff. That being said, there's a lot of stuff. He had like notes and sketches and math and stuff like that never would have been classified. It was just stuff that he did. And so we still found a ton of material, unpublished papers and stuff like that. And that's the important part, trying to preserve this legacy. So we did not find any smoking gun stuff on UFOs. Not that I could see. I didn't see anything like that, unfortunately. And Jared really thought this guy might have been involved with designing the TR-3B. And in a weird way, a lot of the stuff that he designed could have been used by that. But if it wasn't by him. Maybe it was
that sounds about what you would find, though. All the archives of what it probably did go into the TR-3B. It's like if it does exist in Israel, is like locked away and. Like
it could be.
Nobody was allowed to sneak out any of them napkins on the way out.
It could be. So the other thing was Winterberg told his daughter, and we confirmed this. We talked about it with her at length. He told his daughter. So Reno is, I guess, northern Nevada. The Nevada test range, right, is farther south. He drove down to the test site. And he told his daughter he was going to Area 51 many times. Now, he may have been going there. He may have been going to another place called Area 11, which is kind of across the state. The Area 11 is where they do all the fusion research. But he told her, no question about this. He said, hey, Astrid, I'm going down to Area 51. Wouldn't you love to go with me? And he said that multiple times. So take that for what it's worth. I mean, this, so there was that. And the other part is, and this is worth putting a pin in. He talked about UFOs with Edward Teller, who invented the H-bomb. That's like a known value, right? We have letters with them talking about UFOs. He was also part of something called QFOS under J. Allen Hynek. So there's that too. So,
those conversations with UFOs, sorry, Tim, were they about specifically UFOs showing up with the H-bomb or the nuclear bomb tests?
No, the letter, the smoking gun letter there was a letter. Edward Teller let him use a couple of photos of like Teller for his book, right? And he wrote him and he said, thank you for letting me use those photos. This was a book that never got published, but he said, thank you for letting me use those photos. Oh, and by the way, you know, as we've been talking about, there's a UFO in the photo that you sent me behind you. You know, like, so
Wow.
that my takeaway on that was that these guys, and these are the guys,
But
right?
was that book never published, or is it sitting next to all of the other information that's locked away somewhere next to the TR3B, wherever it may be?
Could be, but my takeaway was these are the top guys involved with the nuclear program, and they were into UFOs. I think that's one thing that we can say with certainty. Now, if they knew anything more, that I don't know. I wish I had something better for you guys.
That might have been what inspired him to work on fusion to begin with. So
I think
it's all
the fusion is about creating antimatter.
Yeah,
for these
it was interesting. It was an interesting time. I mean, you know, but
have you seen the Bob Lazar tapes from what's his name channel? The name he just released, Anthony. I forget his last name. He just released the Bob Lazar tapes that were hard to find.
well, he did. There was that movie that came out a few years ago. Yeah, I know Bob from way back, but
I was watching it again. He said that they were creating antimatter with a fusion reactor, for the gravity generators. The antimatter would hit would fall down, and it would create a fusion reaction that would create so much heat, then that heat would be distributed onto a 100% efficient thermal electric generator, which is hard to believe exists.
I mean,
but if
you believe Bob, right? Which, and that
a lot of skepticism right there for sure.
Well, hey, a 100% thermal electric generator is hard to believe. That's the only thing that's hard to believe. The rest of this stuff is, but it's something that's hard to make too. I mean, almost impossible to make something like that without novel materials that we don't have here, or we haven't found yet, at least, that are here.
So with Winterberg, all of his drawings and schematics. Sorry, I didn't have my headphones on, right? All of his stuff was definitely human. There wasn't any, like, just from looking at it, like when I was looking at it, none of it looked like you'd pick it up from ET. It all looked like human type fusion designs, you know. Some of it was really advanced. They had some really interesting stuff. Like, I mean, he had stuff that would absolutely fit with the TR3B, right? Like, you know, and again, Jared can talk more about that, but like micro fusion propulsion stuff. I mean, it was all there. And
Jeremiah's mentioned like acoustic aspects of levitation regarding parts of the TR3B system in discussions with me in the past. Have you heard anything like that, Tim, or no? Just a few.
No. This was fusion, micro fusion explosions. He did get into aether theory. He wrote a book on aether theory. In fact, Jared's going to scan that and try and get that out to everybody.
Microfusion.
Aether theory?
Interestingly, he wrote a book on aether theory, isn't it? Which is weird because he was like establishment. He was an establishment guy, but he was fighting the prevailing establishment. And then let me see. They had some interesting stuff, like you can use X-rays to suppress a superconductor, and then you can, right, and which is just, you know, little, like, these are like little engineering hacks they came up with, right? Like, and so
Hutchinson-esque ish kind of.
Well, we'll get into it on APEC, Tim, but I use the instabilities that electrical engineers purposefully try and get rid of in their circuits and in their systems because it blows them. And I took them all, put them together in order to create a working system. So,
well, this might be an aside, but you know, when I was doing this, goes back to a Philadelphia experiment story, and I was working with James Coram and John Daring on it. And John Daring worked at a defense contractor down in California. And Gerald, what's interesting about what you're saying is he made the claim that these unified field theory effects, or like torsion shear, which might be what's going on in the Graviflyer, The claim that he made was these show up as instabilities, and electrical engineering got rid of them in the 1930s. They designed them out, right? Because, like you said, it like you get fields that collide, and it creates mystery losses in your motor, or it blows your amp, or you get these weird nonlinear effects. And he was like,
parasitic capacitance and dichotron instabilities, and absolutely.
So stuff like that, and maybe not all of it, I don't, but from what he told me, and this goes back a ways, he was saying stuff like that, some of those are actually unified field theory effects where you're losing energy because you're changing the vacuum. And he's like, so it looks like you have this problem with efficiency, but he's like, yeah, it's because you're spinning the aether with you. And he's like, but if you do that the right way, you can create really big effects. So
yeah, I don't use one, I use them all.
Right.
Yeah.
Right.
The more extra inputs of cohesion and alignment in the fields and the waves interacting, the amplifying the effects of it. And it was funny, Tim, you appeared right before I was talking to my dad about the last APEC, where Drew was talking about how he got a little bit of extra overpower after his experiments. And it's like he's wondering where it's coming from and stuff. And it's like these guys here, their engineering minds have been like trying to harness those different extra energies and fields and stuff and put them into usable schematics for a while now. And could be a nice blend of it all.
Absolutely. I'm at the point now where I can control heat in my primary, my secondary. I can make the system go absolutely cold. I can move the heat around to different pickup coils on the outside, or I can turn the system on and take a lighter and put it in the middle of the open core coil, and I'll get voltage on my pickup coils on the outside.
So cool.
That is
a very neat system.
That is cool. Do you have like a measurement tool? You know, like they have the thermal cameras, or like that would be really cool, especially
I have the thermal laser, and I have a infrared camera as well that you can look at it when it's working. And the funny part is, I've done a video.
I saw that video.
You seen that? You turn the coil on for
it was a little cooler. I saw that.
30 seconds, and the temperature goes down, and then you shut the coil off, but you can see the resonance in the infrared camera, and the coil's not hot. It's actually cooler than the rest of the room.
It's not typically normal for a coil to get cooler, but to stay at the room temperature, that's normal, or get a little warmer.
Well, but maybe the thing that I wonder about, like, so Searle effect is supposed to run cold. A couple others are too, right? And one of the ideas was that they supposedly, I'd read that they run cold because it's taking energy from the surrounding
It's an
environment.
endothermic.
Yeah, it's cold. It's a cold energy.
I think it's got
and
to do with
the thing is, this is a marker for free energy devices. I believe.
Yeah.
You know, when looking for this as a marker.
Because that's your energy source where, boom, you're not breaking the second law right there. It's like you're taking energy from the environment, not the vacuum, the environment, and turning it in.
Yeah, but remember, heat has to go
Lenz's
somewhere.
law has no room here.
Remember, heat has to go somewhere. So either you're using the vacuum to put that heat in there, in a sense, or you're using that heat along with the system creating the voltage from that heat into a load. So you're cooling your system down, but the heat from that system is going into your load. Otherwise, it wouldn't work, because that's how I can balance my primary and secondary, by using the load off the back end of the circuit, which is part of it. Right?
Yeah, that's interesting, man. That's really interesting. It sounds like you're like right on the edge of a bunch of stuff, you know?
Yeah, today I made my coil levitate once from the primary, twice from the secondary, and then I made it hop 8 inches and then come down to 4 inches above the original levitation point. And then I was able to turn a dial and slowly make it come back up and slowly make it come back down. So Yeah, crazy stuff.
I was-
We're
I was
on the
telling Nathan.
edge.
I was telling Nathan earlier, Gerald, that you're gonna invent a new way for us to play horseshoes.
Yeah,
I saw that.
Yeah.
That's cool.
we're gonna get
While we have
Sean
Tim and
Clark.
Sean together, Sean, do you want to talk a little bit about what you've discovered with Tesla coils and how it's like applying to the Nathan as well with the Graviflyer? Because I know Tim, you've been following the Graviflyer a lot. That
Sean's way of building a Tesla coil is completely outside the box, and it's like next level.
Yeah,
Absolutely next level.
you won't find anything else like it on YouTube.
With him building the heart of a ship, we'll be there in 6 months, Tim. I'm telling you. Go ahead,
I
Sean.
appreciate that. No, I appreciate that. If you're interested, Tim, I did a 45-minute presentation at the start of this cast, and I go in a bit more depth on what I'm working on. But basically, I'm designing Tesla coils of immense power, but they're small. So I have this 4-inch diameter sphere that I wound with 3,000 turns of 32 gauge wire. I submerged it into an epoxy in a vacuum chamber to remove all the bubbles. And then I made that the secondary of my Tesla. And then I created a concave loop of 1/4-inch pipe as the primary of the Tesla coil. And what I'm finding is I'm able to get 3-4 times the size of lightning bolts flying out of it. And yet, when I tune it, there's no radiant energy from the sphere. Here's an example.
Wow.
So it's not quite tuned, but it's almost tuned. So this is almost as efficient as I can get it. But this is just one of the outputs that I can achieve with the goal of getting to 1,000,000 volts, yet put on my desktop. One of the fascinating behaviors is I encased one of my coils into 1-inch thick epoxy walls, and yet I can see the plasma discharge go right through,
The epoxy.
and as if that epoxy wasn't there. And I don't know if it's quantum tunneling. I don't know. It's just absolutely a phenomenon I haven't seen. But you can see here also, this is a top view. I'm putting my camera only about 4 inches from the top. Not my camera, my phone. And yet there's no EMP. There's no electromagnetic pulses that would normally affect electronic equipment. And it's because this sphere, this unique shape, seems to be efficiently processing all of the electromagnetic radiation to give it into this clean discharge. And then Nathan pointed out something really interesting, and that is if you look at the swirl, there's some effect where maybe it's drawing energy in versus pushing energy out.
Could you do a sphere? Let's see, I'm now messing with my own head. Could you do a sphere within a sphere?
And have one of them the primary, one of them the secondary, and have it as a Tesla coil?
Yeah, like you've got the primary sphere there, right? What if you were able to do that secondary as a sphere around it? Then you could make it really small, and then maybe you could pop both of them or something. You know, that is really cool.
I appreciate that. That's a really interesting idea. I'll definitely put it on my list of testing. Thank you for that.
Yeah, well, I was just one. The other thing, somebody was talking about this earlier today. They were saying that the Tesla had the ball on the output, right? So that it would be interesting to see if you were able to put this entire thing in a sphere. You could make this whole sphere like the output instead of having a pin, like
yes,
And I'm not sure what that would do, but like probably you'd have a lot more field output and less like sparks.
Well, you'd have more field compression by far. Yeah.
It would add a tremendous amount of capacitance, yet with no pointy edges, it would hold as much charge and as much energy as it could, and that would probably have effect on its output. I wouldn't get any discharges like this, no sparks, but
Yeah.
it'd be working on the reverse of trying to push out as much radiant invisible energy to power remote sources or remote objects.
Yeah, you'd have a massive field, right? Yeah.
That's what I'm thinking, because I can get a massive field around this when it's out of tune. That's another one of the anomalies of this. When it's in tune, I get no fields. That's why my phone can hang over these lightning bolts. But if it's out of tune, it radiates energy more than the average coil.
Yeah, that's really interesting. It's super cool. I've never seen a spherical Tesla coil like that.
Thank you. Nathan, can you pull up the picture where it's in my hand and you can see the epoxy, just to give Tim an idea of what it looks like physically?
Give me a second.
I got a question for you, Sean.
Sure.
Are you grounding your secondary out at all when you do your experiments?
Yes.
So where you put your ground, do you ever make identical opposite coil?
Oh, wow. Wow, that is beautiful, man.
Run your ground for whatever distance you decide in this experiment, and take your opposite coil that's identical to your first one and set it up with a capacitor to ground. And I'm betting that you're going to get more energy than you think of.
So they basically have an inductor capacitor at the same resonant frequency as the sphere, and then see if that it's able to transfer that energy out through the ground.
Exactly. Ground both systems the exact same way, just to test to see what your distance could be. And using your ground is actually your power transfer.
Well,
that's a really interesting idea. Thank you.
Yeah, that is beautiful. That is absolutely beautiful. So with the way that you have this wound, then when you do the secondary around that, you're I think you're losing a lot, because you've got that plane, right? And the sphere is kind of, but yeah, it would be really interesting to see if you could go in a sphere around that.
Yeah, yeah.
Maybe you would have better transfer. You know what I mean?
Yes, that's kind of why you'll see a top load on Tesla coils, because it builds a bigger charge before then it lets go. What you're saying is basically build a top load, which is just an external sphere, and that would build a much larger charge to see before it discharges. So that's a really cool idea, Tim. I appreciate that. I'm gonna definitely try it.
Dude, that's beautiful. The way that you wound that's beautiful. That's like a work of art, man.
I appreciate that. Thank you so much. Nathan, could you show them the coil video that I roll, my latest, the black one?
Yep.
Yeah.
Cylinder.
I was just trying to show them the primary and secondary you put on this.
Oh yeah. Show them how this how it's not working right.
That's so beautiful. Wow.
See that? That's some serious plasma discharge right there.
Yeah. So it looks like it's
plasma time, guys.
It's blinding.
Yeah, but you see when it sparks over, then the outside lightning gets way bigger.
So your secondary is shaped like a standard secondary Tesla coil, but it's epoxied in a sphere.
Correct.
And coming out the tip, you have the.
So if you were able to epoxy that, secondary, right?
Yeah.
If you did the secondary, then maybe you could get rid of that arcing over.
Well, it was just some adjustments, and the arcing over stopped. But the outside sphere that you're mentioning, to see if I can, that's just fascinating. I have to try that. It's just
dude, I think that's beautiful, man. That's.
Thank you. This is 5,000 turns of wire on a cylinder. And what you're seeing here is when I change to the next level, as I wind 50 windings per level, and it's 100 levels, that's what this gap is here for. And then there's a little video where I roll it because it's translucent in the light. And I think it's the next one after this.
Yeah, give me a second.
It just kind of gives you a sense of what I'm working with, and it has this such an aesthetic quality while it's also functional. And also seems to just be breaking the rules. I don't know why. It's very fascinating.
I have a suggestion for you for an experiment.
Sure, I got my notebook here.
If you can find a large enough glass borosilicate bowl and put it over your coil, just be ready for the outcome, because you're going to contain your field and your electrostatics, and I think your wireless ability is going to go exponential. Could be wrong, but it's worth testing.
It's definitely
if it's glass, you will amplify the aether energy.
Borosilicate glass. There's a reason for that.
So the glass, you would just leave it on. Maybe you could pot. Do you think you could pot it
That's
inside the
interesting.
bowl?
I'll have to try that with my coil too.
Say that again, Tim.
Well, like, what if you had a couple of bowls to do your sphere? What if you had a couple of bowls? You could just drill a hole for the wire and then just pot it right in the bowls.
Interesting.
It sounds kind of similar to Dan Foster's like double circular bifilar. No, that Jeremiah built one of. You know what I'm talking about, Gerald or Tim?
His was a little different.
A little
The
different.
way he wound his was unique, so it's not quite
Thanks,
the
David.
same. It's spherical, but it's not quite the same. It would do different things. The fields are compressed in such ways that it's hard to actually imagine for me, but unique. Like, I can't wait to see the whole thing done.
There's so much to coils.
Yes.
And,
Yeah.
I love them. I love them.
He's epoxying them to keep the high voltage from the atmosphere.
Wow. Yeah. See, that is so cool. That is so cool.
What is that?
Not easy to print, not easy to design. It's 100 grooves at 1 centimeter depth. Just fresh off my Bamboo Labs printer. In the next slide, you can
shout
see
out Bamboo Labs. You know, if you want.
I love to get access to that file for 3D printing, if you don't mind.
Yeah, I'm keeping it on a friends only basis. So Ben, I'll be glad to send you one.
I appreciate that, because that doesn't look like too involved for me as a project.
It's a bear to wine and it's a bear to epoxy, but it sure is pretty. You're a awesome coiler, Ben. So you'll have no problem.
Yeah, I'm pretty experienced with these coils, at least the rodent coils. I'm looking to expand to different shapes though, and Gerald's been very kind and helped me with that too.
Cool. Yeah, I have the donut or the toroid and a sphere. Those are the ones that are on my list right now. I haven't finished testing the sphere, and I haven't finished winding the toroid yet. Toroid is so hard to wind. I don't know. You've seen the donut?
Yeah.
I'll say this, Sean. You've given me another perspective on how to wind these coils. I'm going to try something completely new I've never done before, just because of the way you've done your system. It's just phenomenal.
Thank you. I appreciate that.
We'll see what the outcome is. I'm at 170 different coils at this point. So
very cool.
Through experience, you get little tips and tricks on how to wind them. I'm sorry, you said what?
I just said Gerald his coils are amazing.
All of your coils are amazing.
Yeah, they're saying toroid coils are hard to wind, and that's what Gerald's winding there.
Right.
Yeah, exactly. It requires experience. You just got to do it over and over again until you get your rhythm of it.
Could take as much as 3 months for each coil. This
is my next level. So I'm putting rectangular wire on here, and so what that means is instead of a 32 gauge round wire like my other coils, this one's 32 gauge thick, but it's 1 millimeter wide. And so what that means is I can still put 5,000 turns of wire on that 6-inch coil, but it's going to allow me to have 5-6 times the amount of current. And current is really the name of the game when you want to see a lot of electrons flying out of your coil. So this is where I'm kind of thinking I'm going to fudge it. And I didn't mention this in the presentation, but the same distributor here They also make 99.9% pure silver magnetic wire.
Yeah, I was going to ask about that. So if you did silver instead of copper, what kind of results would you think you'd get?
Higher efficiency.
Yeah.
Depends
So,
on what you're hoping. Go ahead. Sorry, Sean.
no.
I mean, aside from
An
being like
empty
totally
wallet
poor, right?
at the end of the
Like,
day.
Yeah.
Besides it being the most expensive coil I'll wind, it'll be money in the bank too.
So you get pure gold
Money in the
wire to
bank,
do the next
a great
one,
way to
right?
hide your cash.
That's right.
So
There's a
is
lot of
there?
coils.
Are you getting that from Amazon, or is there a specific distributor? Because I'd love to order both the rectangular wire and the silver.
Well, I'm looking for somebody to actually go halvesies or something with the silver because I just can't afford a 20-pound roll. But yeah, if you're
You can
interested,
all go 120s into it, so get a couple coils each out of it.
yeah, I'm totally open for it.
Yeah.
So what I was ordering off of AliExpress.
Just make sure you practice on a copper wire first. You don't want to wind with the silver wire and screw it up.
Oh yeah.
What's up, Darren?
Always.
What's up, Anthony?
That's
So
just my 2 cents. That's all.
No. So a salesperson from China somehow got my email from AliExpress and said, "Hey, don't worry about AliExpress. You can order straight through me." And at first I was like, I don't know. And so I told my wife, "Look, I'll take a chance because I want that rectangular wire." Yep, came in just like I wanted it. So I ordered a second coil, 20 pounds. Listen to this, 20 pounds of copper wire for $160.
Oh,
That's cheap.
beautiful.
You can't even get 5 pounds.
Like the Chinese
China?
military researchers want you to succeed and afford
How
the
pure is
next
it? I mean,
level of
it's from
experiments,
China.
right?
Are they
Like,
synthesizing it?
Oh my goodness, I didn't think that way. Oh my goodness.
you never know, right?
Right.
Yeah,
right.
if they could be, it could be really cheap because they could be growing it or synthesizing it, transmutation or whatever.
China mixes aluminum in a lot of their metals. They've been doing that with the Tapcons, or they're supposed to be 100% steel, the Tapcons, but if they break, there's aluminum in there.
So I don't know if you guys are interested, but I can do a few picks if you want. I got to test drive the Cybertruck.
Ooh.
Oh, heck
wow.
yeah.
I'll do a
Look at
quick
that. Our Tim Ventura competing with the Chechen warlords.
That's
Also
right.
test drive it, right?
Because I have a Model 3, right? I have a Tesla Model 3, and it's little, but I love it. I absolutely love it. Because gas in my area, because I'm near the Canadian border, gas is like $6 a gallon. So I had to go to the dealer.
Alberta border, man, it's way cheaper. We're the Texas of Canada.
And so I got to test drive the Cybertruck.
Oh, that's nice.
Yeah.
Good tune.
Oh, okay, you can hear it?
It's
Okay.
auto drive?
Yeah, we can't. Yeah, this is going to get us flagged.
Yeah, you might want to mute that.
Is that the stereo in there?
Uh-oh.
That was the stereo. So this is the
Was it Boston?
sliding thing on the back. And that's it. And then this is the new Model 3s. These the new. So that's the deal. This is down in Seattle.
Wow.
Yeah. So the Model 3 is I really like those, but the other one is too big. So that's all I have for photos. But
that looks fun.
That's awesome, Tim.
Yeah.
Absolutely.
So I would say my takeaway on that is I mean that's a massive, it's a giant vehicle. Like it's big, right? So
Wow.
if you're used to like F-250, F-350, then you'll probably like it. But if you're used to driving something that's like normal size,
250, 350, okay.
Wow.
Because I sat down in that and I was like, because it's like you see it online, it looks really cool, right? And I was like, I want one of those, And then when I sat down in it, I was just like, no way. There is no way I would buy this. It's just too big.
Wow.
Too bulky to turn like it's square, no? Yeah.
Well, okay, so I have a question regarding this because it's like literally the day before the Chechen guy came out with the whole militarized Tesla tech or truck. There was an American company that came out with 3 different kits for covering like the Tesla trucks, fully militarized and stuff, and we're like selling it and like promoting it. And it's like, so is this like the future? Are they just gonna be like what? Is like the Tesla truck the new Hummer, or what's going on? The drone.
I mean, so remember when they came out with the Hummer 2 and people, they had the same reaction that I did when they came out with that thing like 20 years ago. People were like, yeah, you know, it's really cool, but it's too big, the whole 9 yards. But what's interesting is it did kind of change trucks a little bit. You know, it made them a little bit more rugged. You know, people, even though it didn't, I don't think it sold that well. It kind of, the truck industry kind of followed a little bit. I'm wondering if that happens with the Cybertruck. I'm wondering if, like, even though it's not, I don't think it'll be a giant seller. I wonder if you're going to see regular trucks start to go that direction a little more. I don't know.
It depends on how
Is it
many charge
self-driving?
locations they make.
Is it? I think it is, or it's optional. I don't know.
So it's potential drone takeover in a 9/11 style conspiracy-minded individual. To say
There's multiple companies out there offering conversion kits for F-150s and F-250s right now. So, yeah, it could become a little bit more mainstream. Hard to say.
Yeah.
Yeah.
No, thank you.
Well, when we were in Reno, we had a Kia EV, and that was little, right? But it was like, you could kind of tell when you got on it. Like with Tesla, they design it electric first. It's like, we're going to create an electric car, and everything kind of works good. But like with the Kia, it's almost like they took a regular car and they just ripped out the engine and put in their electric system and changed the controls. And we had so many freaking issues with that thing. I mean, just little stuff like you shift into park and the parking brake comes on automatically, but then it doesn't release automatically. And it's just like, you know, Jared would get in it. And like, I thought this was me. I was like, maybe I'm doing something wrong. I shift into drive and it won't shift. And it's like parking brake engaged, but then it wouldn't disengage. And I'm like, okay, I'm retarded, right? I'm doing something wrong. So like the next day he got in the car and the same thing happened to him. And I'm just like, okay, it's not me, it's this car. It sucks. So
There's been accidents like that. I heard.
It sounds like their ground, they had a problem with their ground and their electrical was bouncing all over the place.
That's a recall.
They had weird stuff too. Like, and then they had a nav system, but like for most nav systems, it either pops up, right? Like you're even Garmin or whatever. It's like, do this next, or else it's a list that scrolls down, right?
Oh,
they're scrolled up from the bottom. And so like I'm looking at it and I'm like, okay, do this. I'm like, what the hell? And so
and it always takes you to the wrong place.
Yeah. I would be careful with EVs because a lot of these manufacturers have not figured out what they're doing yet.
The thing I can't imagine is I'm trying to visualize driving with a square wheel, and I can't, or a rectangle shaped wheel.
It's a drive-by-wire, right?
Rectangle shaped
The
wheel.
strange driving is drive-by-wire.
Yeah, the wheel is rectangle shaped.
What?
On the
Maybe
Cybertruck.
no ones. I think
Here,
that
let
might
me
be.
Google it. Why the square Tesla steering wheel?
Oh, the steering.
Yeah, is there a reason for that? Maybe it has a practical application or
Steering
something.
wheel, God.
Okay, Elon Musk says the flat
don't know, that
bottom
just would-
rectangular shape looks cooler and makes it easier for drivers to see the instruments.
Oh, that makes sense. Okay, never mind. Yeah,
But it
because
doesn't say-
I'm just trying to picture driving with a square wheel. It seems a little odd, but I knew there had to be some kind of reason for it.
Are the edges smooth?
Well, everything in the interior should be. Oh, here we go. Yeah, Bernie wanted me to pull up some videos, and I didn't have access to them, Nathan.
Oh, sorry. I'll let you guys finish your
Sean's.
conversation. Go ahead.
Oh, okay. Yeah, no, I was just saying, like everything in the interior, they like to design it with a purpose, you know.
So there's another article here that says Formula One drivers can recognize the wheel's orientation by feel when it's square, right? I don't know that.
Huh.
I think that's bunk because most wheels you can kind of tell, they've got the notches for your thumbs anyways. I don't know.
Right.
Again, I was
I think it's
like
personal
You
preference.
don't drive with the square wheel, so I don't imagine.
Oh,
it,
so
like,
these manufacturers are appealing to race car
Bernie's not a
drivers.
square.
I want a triangle wheel now, just because you
when
guys
you're
are
rolling your round, the universe spins. There's just something to it.
That's very
But
true.
some of that stuff, I mean, like, some of that stuff is what you're used to, right? Like, I heard a long time ago somebody came up with a joystick control for a car. I'm like, I couldn't do that either,
Yeah,
I think
I don't see that happening.
There's like an age limit for some of that stuff.
Yeah, no, thank you.
I don't know. I'm
Yeah.
going to stay as young as I possibly can. Even if I'm 75, I'm going to jump out of an airplane. I mean, life's short, right? Take it one day at a time and do the best you can with it. That's all.
I'm not getting in an airplane. No, thank you.
How about we take it one step further? We're
I'm with
gonna
you on
jump out
that,
of a
Nathan.
Graviflyer.
Oh,
I'll jump
We had a
out if
gravel
I have
flyer.
to.
We had to grab a flyer. I wouldn't jump out of it. We just be going somewhere.
Dude, I'd have no problem getting in a jet where I'm in the cockpit, but in an airplane, no, thank you. I want to be somewhere close to the controls because I don't trust a lot of people. And I have no problem going out cold in the middle of that flight. You know what I mean? As he hits those turns too fast, not a problem.
Hey, Nathan, you know
I
what my
hear ya.
T-shirt says? I don't trust people. I don't trust words. I only trust patterns.
Yeah.
cool.
Available now at my merch shop.
There's a
Yeah,
plug.
you want to play this? Check this out. This is also cool. This is one of his designs here. This is a handheld Tesla coil.
That is cool.
Just a plain blank.
Yeah, that's
circuit
neat.
board blank. Electricity seems to know where ground is.
That's
Oh, this is
insane.
Yeah,
my
wants to go to
4-inch
Mother
coil.
Earth.
Yeah, that is so cool.
Should do that with a vial full of like a bacteria or something, like,
Oh, that's interesting. That's pure continuous wave electricity.
Or tadpoles. Okay? A jar of
Right.
tadpoles.
Tadpoles.
Just to see. That's interesting.
I mean, if you can't do the electron microscope, then yeah, tadpoles.
Just do it
Speaking
to
of
some,
tadpoles, I got some in my yard right now.
do it to some pond water that has a lot of organisms in it.
I wonder what would happen if you pre-ionize the air. Would you'd probably get massively larger fields, right? Massively larger sparks.
I think so because ionized air has a lower resistance. So, yeah, I don't know if you've ever seen plasma go through a partial vacuum. It would probably have something like that effect where it would just double or triple in size.
Oh yeah, yeah.
Like the star in a jar thing.
It's cavitation.
That
Yeah, that is so cool.
That's an
Gentlemen,
undesired effect.
I gotta bail out on you for tonight. Thank you for having me on. I appreciate it.
No worries, brother. Thanks
it's
for
fine.
stopping by, Tim.
Nice meeting
Yeah.
you, Tim.
Yeah, thank you, Tim.
Thanks
Yeah,
for coming.
have a great evening, guys.
You too.
You as well, bro.
Take care.
Oh, that was awesome.
You know what we
Always a
need to do,
pleasure.
guys? At the end of the month, we'll see if everybody who came on wants to come on at once. You know what I mean? I think that'd be cool. I think we could put something like that together because we had
Sure.
some fantastic people come on, man, and just a cross conversation I think would be
Mhm.
amazing.
The
Yeah,
ultimate
all these
Fringe
minds
think
thinking
tank
outside the
episode.
box, conglomerating.
Yeah,
Forgot about it. We're gonna be
Dangerous
there.
thing. Things are being built. Fields are getting stronger.
So Nathan, I need a hand on a circuit later.
Yeah,
Uh,
I got your message.
Yeah, I figured out how, on the last video I did, how it hopped once, hopped twice, and then I made it hop the third time, and then
you held it up.
Yeah, and then it stayed there. Okay, I was saying this to Tim earlier. I'm not sure if you're around. I figured out how to make it raise slow or lower slow or go to the middle of to where it was.
Okay.
But I'm blowing variable resistors like crazy, and I need some help on my math to figure out what I need to make that sucker balance with its resistance, if you know what I mean. And I have an idea where I'm not using a variable resistor or resistance at all. Sorry, I'd be using resistance, but not a resistor. So something I want to discuss with you in that as soon as we can.
Might have to bring Sean in on that. I'll tell you what, Sean's the man.
Yeah.
Appreciate that.
You're the circuit guy, Sean? Is that it?
Gerald, those potentiometers don't really do very well. They burn out easy.
Oh, yeah, you should have seen the way this one lit, man. Lightning